AI is ultimately an energy-hungry beast. It's a phrase that has become increasingly common in discussions about the AI industry. Running large-scale AI systems like ChatGPT requires thousands of GPUs and massive data centers. This has led to growing interest in technologies that can move data faster and more efficiently. One of the most promising is silicon photonics. The limits of electrical connections. Contemporary computers are built around several semiconductor components that function together, including CPUs, GPUs, and memory chips. CPUs oversee general system operations, GPUs execute highly intensive computations, and memory retains the data required for processing. Information moves continuously between these parts, and for decades this exchange has relied on electrical signals. However, the AI era is exposing the limitations of this approach. Today's AI systems often connect thousands of GPUs simultaneously. As electrical signals travel through copper wires, they generate heat. Increasing transmission speeds requires more power and more sophisticated cooling systems. As the number of GPUs grows, so do energy consumption and heat generation, making it increasingly difficult to scale AI systems efficiently. What makes silicon photonics different? As its name suggests, silicon photonics combines silicon with photonics, the technology of transmitting information using light. Silicon is the fundamental material used to manufacture semiconductors, which means silicon photonics can be produced using many of the same manufacturing processes already used by the semiconductor industry. Traditionally, information has been carried by electrons moving through copper wires. Silicon photonics replaces those electrons with photons, the particles of light. In simple terms, tiny pathways are built into a chip to guide light, and data is transmitted through optical signals. Light generates far less heat than electrical currents and suffers less signal loss during transmission. It can also carry much larger amounts of data at once, making it particularly well-suited for the enormous data flows required by modern AI systems. Why do AI data centers need light? Large AI models such as ChatGPT, Claude, and Gemini do not rely on a single GPU working alone. Instead, thousands of GPUs work together, continuously exchanging information and calculation results. As AI systems increase in scale, raw computing power is no longer the sole factor that matters. The speed of data transfer between processors has become equally important. If communication between GPUs is too slow, even the most advanced hardware cannot deliver its full performance. In the past, the semiconductor industry focused largely on building faster CPUs and GPUs. In the AI era, however, the challenge has shifted toward creating massive systems in which thousands of chips can work together seamlessly. Against this backdrop, silicon photonics is emerging as a key technology for improving data movement and connection efficiency.